Transforming quadratic functions. All right, in order to talk about transforming quadratic functions, you guys must know or be familiar with the vertex form. Some textbooks call this the standard form. I like to call it the vertex form, mostly because the vertex is right in the function, the hk. The vertex, hk, is a really important and unique point when looking at a parabola because it's the point right in the middle. That's your vertex. The vertex could be on the bottom or it can be on the top. So that is also where you're going to find your maximum or your minimum values. So like if this was hk right here, the k would be your max. That's just a side note. But let's talk about quadratic or transforming them. All right, so the very most basic quadratic function that you guys probably know about is x squared. So how does this guy right here relate to all this nonsense right here? Well, the a would be a 1, the h would be a 0, and there's a squared, and then the k would also be a 0 for this function. Not so with this function right here for my first example. The a is a 3, the h is a 5, and the k is a -2. This one is very clear. So you can see all the different parts, the a, the h, and the k. You also might run into other ones that aren't so clear. Like, let's say this one says, I'm just going to make this up, negative x squared, we'll say minus 15. Okay, so what is the a, what is the h, what is the k? So if I put parentheses around the x, it might kind of help you see some things. There's a -1 in front of the x that is being squared. The h is non-existent, so I'm just going to add 0, or I could subtract 0, it doesn't matter, and your k is going to be 15. Okay, I'm done with identifying things. Let's take a look at our first example. So this dude right here is our function. How would he look? All right, so we're going to start with our vertex since he is the most unique point on our parabola, and it looks like our h is 5 and our k is -2. Now I know this says negative right here, but you always need to think the opposite when you're looking at the h. Whatever is adding or subtracting to the x inside parentheses, you got to think the opposite. So this says -5, but I'm going to think +5. So we're going to go over 1, 2, 3, 4, 5, and then we're going to go down 2. So there's my point right there. That's my vertex. And the next question is, which way is my parabola facing? Is it facing up? Oops, I missed it. Or is it facing down? In this case, because the 3 is positive, we're going to go up. So we would go up like this, and then that's it. That's a general way to look at how you do this. Now, if you want to be a little bit more specific, you have to know what the 3 does, what the a does to my graph. If the 3 is, or if the a is greater than 1, then it's going to make the graph skinnier. If the a is less than 1 but greater than 0, then it's going to make it fatter. Let's take an example, or look at an example. So to do that, I'm just going to pick 6 and I'm going to pick 4. So I'm just going to pick the 4 and the 6 and I'm going to plug it into my x and do a little bit of mental math. So if I plug in a 4 right there, it'd be 4 minus 5, that would be -1. -1 squared would be a +1. So that would be 3 times 1, so that'd be 3. 3 minus 2 would be 1. And then I'm going to pick a 6. When I plug a 6 in, it's going to be 6 minus 5, which is 1. Squared 1, 1 times 3 is 3. 3 minus 2 is also 1. So it looks like our parabola would be something like that. Okay, we could pick more numbers. We could pick a 3, we could pick a 7, but it's not necessary if you're transforming. You just have to know the general transformations, shifting and squeezing or getting fatter. You just have to know the general happenings. All right, so let's pretend that this was not a 3. Let's pretend that was a 1/3. Okay, so I'm going to change the a to be a number that is less than 1 but greater than 0. Okay, so now my a is less than 1 and greater than 0. What would happen when I plug in a 4 this time? If I plug in a 4 right here, that would be 4 minus 5 be -1. -1 squared would be +1. And then positive 1 times 1/3 would be 1/3. 1/3 minus 2 would be negative 1 2/3, which would actually be right there. And then for the 6, when we plug that in, you'll see we'll get the same thing. And so our function would be more like this. So you see now my parabola just got a little bit fatter. The other thing that a can do is that a can flip it. So if a is less than 1, let's pretend a is less than 1, that means, I'm sorry, not 1, 0. That means this would be a negative number. Now the only thing that changes is it takes all the y values and switches them. So instead of this y value right here being up there and those two, we would go down instead of up. So it would be 1, 2, 3, 1, 2, 3, it'd be 1, 2, 3 right there. So it would flip the function over. Okay, last thing I want to show you guys is the different ways we can write what we have right here. The way I wrote it is identical to the way the formula looks, or the general vertex form looks, but you can see it in different ways. You could see it like this. You can see y equals negative 2 plus 3 times x minus 5 squared, which would be kind of weird because now this negative 2 is the first number instead of the last number. But that doesn't change the negative 2. The negative 2 is still going to be the k in this situation. I guess the thing you have to remember, or the thing you have to know, is that the 3 right here, the a, would always be multiplying to the x. Okay, the h, which in this case is the 5, would always be inside parentheses with the x. Okay, so I'm just going to put parentheses. The h is always inside parentheses. And then the k, the last number, is always the constant. Like he's the one that is not adding to the x. He's not multiplying to the x. He is happening after the squared. And the squared is what defines this function, the quadratic.